Okay, this is the P2 paper from June 2022. This is question number 8. And if we look at it, we can see this is a differentiation question. And also this is a finding stationary points question. So let's jump straight in. We've got that for part A, y is given by this function, 256x to the 4 minus 304x minus 35 plus 27 over x squared, and what I'm going to do is get this ready to be differentiated by calling it 27x to the minus 2. So I put it in a format where that can be differentiated. So differentiating is multiplying by a power and taking one off the power. 4 times 256 is 1024. Take one off the power, x cubed minus 304. The 35 will disappear, and again with the last one, multiplying by the power, multiplying by minus 2 gives me minus 54. Take one off the power, gives me x to the minus 3. So part A done. Can we find the differential, dy by dx? Yeah. Part B says, hence find the coordinates of the stationary points of the curve. So stationary points occur when dy by dx is equal to 0. Let's just tell the examiner I know that. So at stationary points, dy by dx is equal to 0. So in other words, 1024x cubed minus 304 minus 54x to the minus 3 is equal to 0. Now, the simplest thing to do is to multiply throughout by x cubed. If we multiply by x cubed here, I'm going to get 1024x to the 6 minus 304x cubed minus 54 equals 0. So here, this is a quadratic equation. And it doesn't look like a quadratic equation, but it's a quadratic equation if you make the substitution that u is equal to x cubed. Then I've got 1024u squared minus 304u minus 54 equals 0. We'll solve the quadratic and then we'll just put x cubed back in. So in trying to solve this, first of all, let's see whether anything divides into it. Now, this is something that we would attempt to try and factorize. This may be one of those where you say, do you know what, I'm just going to stick it all into the quadratic formula and work it out. I'm pretty good at factorising, so I'm actually going to, first of all, divide by the highest common factor, which means halving everything. So 512u squared minus 152u minus 27 is equal to 0. And then we're trying to find factors of this, and the key is 27. So if it's 27, I'm going to do 1 and 27 as being my constants, or rather 1 and minus 27 as being my constants. So go ahead and try and factorise it. It actually works out to be 8u plus 1 and 64u minus 27 there. Right, if we get that, we then get that 8u plus 1 equals 0. So u equals minus an eighth. We get 64u minus 27 equals 0, which gives me u equals 27 over 64. When we were trying to work out, well, where do we get those numbers from? You know, your 8, your 64, your 27, and your 8. Think about the fact that we're going to have what we get here, x cubed equals to something. And so having cubic numbers as part of my answers here is very clever on the part of the examiner, but gives me a little bit of an in into trying to work that out. So if x cubed is equal to that, x is the cube root of that, which is minus a half. If x cubed is equal to 27 over 64, x is the cube root of that, which will work out to be 3 over 4. We actually wanted the coordinates of the stationary points, so I've got to put those back into the equation to work out what the y values are. So we're going to have y working out to be 256 lots of minus half to the 4, minus 304 lots of, minus a half, minus 35, plus 27 times minus a half to the minus 2 there. And if you actually do all that, obviously, you'd have to plug that all into the calculator, but that works out to be equal to 241. And if you do the same thing, but with the 3/4, so we're going to get y is equal to 256, equals to 256 3/4 to the power 4 minus 3 over 4 3/4 minus 35 plus 27 3/4 to the minus 2. And just be careful plugging all these values in, but then y works out to be equal to minus 134. So our two answers are 3/4 and minus 134, and minus a half 241. And that's where we get quite a few, what was that worth, 5 points? Yeah, 5 points there, simply because there's quite a bit of work to do. Okay, hopefully that makes sense.